Hello everybody, getting ready to do lesson 7.4 of Algebra 1 Math. It will be part 1, 7.4, and this is your standard here. For this lesson, we have a 32 points classwork sheet here, skill sheet of 32 points here, and then we have a note-taking guide of 7 points possible. Write and graph exponential growth functions. Here is the standard here. And here's your bell work, teachers, for today's lesson. Give your students 5 minutes to complete these. Okay, welcome back for your solutions to your bell work. There's A, there is B, there is C, and there is D. So students, if you did not get these, correct your own work. It will give you this opportunity here to correct your own bell work. Or teachers, you can have your students hand them across the aisle or whatever you want to do in your classroom. These are the correct answers to these exponents. Okay. Write and graph exponential growth functions. You wrote and graph linears. You will write and graph exponential growth models so you can find the value of R. Okay. Car auction. Exponential function is a function of the form y equals ab to the x, where a cannot equal 0, b is greater than 0, and b cannot equal 1. Exponential functions are nonlinear functions. Observe how an exponential function compares with a linear. So, students, in your own words, define exponential function. This goes in your notebook. Okay, linear function, y equals 3x plus 2. So we have y, we have x. Start with 0. When x equals 0, y equals 2. When x equals negative 1, y equals negative 1. When x equals negative 2, y equals negative 4. When x equals 1, y equals 5. When x equals 2, y equals 8. So that is your table there for this function here. So we have a difference there of 1. We have a difference there of 1. We have a difference there of 1. And then we have a difference there of 1. And then for output, for our domain, we have a difference of 3. We have a difference of 3. We have a difference of 3. And we have a difference of 3. So all these are the same. They increase by an increment of 3, and as these have an increment of 1. Exponential function now, y equals 2 times 3 to the x power. A little bit different than this up here. So what happens with that? Here's our table, x and then y. When x equals 0, y equals 2. When x equals negative 1, y equals 2/3. When x equals negative 2, y equals 2 over 9. When x equals 1, y equals 6. Then when x equals 2, y equals 18. So what do we got here? We got a difference of 1, 1, 1, 1, still the same difference. In our domain, what about our output? Times 3 is multiplied by 3 here. Multiplied by 3 here. Multiplied by 3 here. And then multiplied by 3 here. What's going on here? Write a rule for the function. So here is a function here. Tell whether the function is exponential. Here's our table, x and y. So we have when x equals negative 2, y equals 2. When x equals negative 1, y equals 4. When x equals 0, y equals 8. When x equals 1, y equals 16. Then when x equals 2, y equals 32. What's going on here, students? Here the y values are multiplied by 2. So as we move to the right here, they are multiplied by 2 for each increase of 1 up here of x. That is what's going on. So we got 2, 2, 2, and then 2, and then up here we're only increasing by 1. So we have a steady here multiplication of our output by 2, and that, so the table represents an exponential function in the form y equals ab to the x, where b equals 2. So that is what's going on. That. Find the value of a by finding the value of y when x equals 0. When x equals 0, ab to the 0 equals 1 equals a. The value of y when x equals 0 is 8, so a would be 8. A rule for the function is y equals 8 times 2 to the x. That is this rule for this table here is y equals 8 times 2 to the x. We found a here, ab to the 0. Okay, let's write a rule. One. Students, you got yours. The y values are multiplied by 3. 3, 3, 3, 3. For each increase of 1 up here, 1, 1, 1, 1 in x. So y equals a times 3 to the x. When x equals 0, y equals 27 equals a. So that would equal our a. So a rule for the function is y equals 27 times 3 to the x. It's multiplied by 3. And then when x equals 0, y equals 27. So that gives us 27 times 3 to the x. When x equals 0, 3 to the x is 1. So it's 27 times our b there in this situation. When x equals 0, y equals 27 equals a. So that would be it. 27 equals a. ab to the x. There's 3. We have an increase of 3 in each of our outputs there for each increment of 1 up here. So that is our b here, is our 3. And then those are increments of 1. So each increase of 1. So y equals a times 3 to the x. Y equals a times 3 to the x, and 27 is a. 27 is a, and that's how we got this, okay? Now try yours, student. Try your independent practice. Okay, graph an exponential function. Graph the function y equals 2 to the x. Identify its domain and range. So I'll make a table by choosing a few values. Here's our table for this function up here. For x and finding the values of y. The domain is all reals, so here's our domain here. And then our output is all reals too. So plot the points. So here's our graph here. So when what is this? When x equals 0, y equals 1, I guess that's what that's supposed to be. And then when x equals -1, y equals 1/2. And then when x equals -2, y equals 1/4. And then when x equals, let's see, x equals 1. When x equals 1, we're going to call that 1, y equals 2. And then when x equals 2, y equals 4. So this is a general graph here. Draw a smooth curve through the points. Once you've got your 5 points here drawn, and there's your curve there for this function here, y equals 2 to the x. The range is all positive reals. The range is all positive reals here. These are all positive reals. The range is all positive reals. We're all above the y, or rather the x-axis here. Everything's positive here. It doesn't cross the x-axis. Okay, let's graph this. Y equals 5 to the x. Students, this is yours down here. Pay attention so you can graph that. Okay, so graph y equals 5 to the x. Identify its domain and range. Here's a table for this function here. All of our y's are positive. Notice that. Everything stays above the x-axis. And then here we go over to the negative side and go over to the positive a little bit. Here is the general shape here of this curve for y equals 5 to the x. It's a pretty steep little curve when it gets over here. Yeah, this is a domain. This is your x values here. Goes like this, and then your y is all positive. Okay, so y equals 5 to the x. Domain's all reals. Our domains are all reals. This is all our x values. And then our range is all positive real numbers. So it's range state. And then here's what it looks like on a graphing calculator. Y equals 5 to the x. And then here's the resulting table from that too, from here. That's what you get by pressing second table set. No, it'd be second graph. This would be your table. So you'd hit second graph and this would come up here. Once you enter into y equals, your y equals, you would enter this here. Okay, and then here is the actual graph on the graphing calculator. Y equals 5 to the x. This is what it would look like when x equals 0, y equals 1. So that would be your y-intercept right there. Okay, that was 7.4, I think. 7.3, 7.4. Part 1, you want part 2? Email me here. You want worksheets, you need tutoring. I do virtual whiteboard tutoring. Email me and we'll set it up. Thank you.